everyone! In this video, we continue with the demonstration on the utility of the metabolism similarity analysis. Part 1 of this video addresses the cases where the metabolic similarity supports the consistency between chemicals with respect to a target endpoint. You can click on the link at the top in order to watch the video on metabolism similarity Part 1. In this second part of the video, we will use the metabolism similarity tool in order to justify contradictory results for chemicals that are structurally and mechanistically similar. As it was explained in part 1 of this video, the metabolism similarity tool implemented in TIMES allows comparison between the simulated metabolic maps of the chemicals, taking into account different similarity criteria. Now, let's investigate the metabolism similarity between two structurally similar chemicals with respect to Ames mutagenicity endpoint. The first chemical in the list has positive Ames mutagenicity experimental data, while the second chemical is experimentally Ames negative. Both chemicals are structurally similar. This chemical too is actually a structural fragment of chemical 1. Moreover, if we predict these two chemicals by the times Ames mutagenicity model, we could see that the model predicts both chemicals to be positive. Now, let's use the metabolism similarity tool in order to explain the inconsistency between these chemicals in terms of difference in their metabolism, which could probably explain the contradictory Ames data. As you already know, the metabolism similarity tool contains three different metabolic similarity criteria that could be used for the comparison. These are transformations, profilers, and common metabolites. At first, let's compare these two chemicals based on their mechanistic consistency with respect to Ames mutagenicity. To this end, we will use the existing profilers available in Toolbox. As you know, TIMES is docked to Toolbox, and the knowledge from Toolbox could be extracted automatically. Now, for the current case, we will use the endpoint-specific profiler for Ames mutagenicity, which is associated with DNA binding alerts. And we will use the hologram approach, which takes into account the frequency of application of these identified DNA alerts. Based on the results, we could see that both chemicals are completely mechanistically consistent. Let's see more details. The bar diagram shows that the same DNA binding alerts, alpha beta unsaturated aldehydes acting by Schiff base formation and nucleophilic addition mechanisms, are identified in chemical 1 and in chemical 2. We can see the metabolites with identified alerts simulated in both maps. We can see that the positive alerts for both chemicals are caused by exactly the same metabolites. So, how we can explain the positive experimental data for the first chemical and negative experimental data for the second one? Let's try to compare these two chemicals again by using of the same profiler. However, this time we will take into account the quantity of the generated metabolites. This time we can see that both chemicals are dissimilar with respect to their toxicity. Let's see the bar diagram again. Here, it is clearly shown that the metabolites with identified DNA binding produced by chemical 1 having positive experimental data is much higher than the quantity of the metabolite with identified DNA alert produced by the second chemical having negative experimental data. Let's see also the distribution of all metabolites. This is metabolite distribution of chemical 1 and metabolite distribution of chemical 2. Let's see where is the positive metabolite. Here again we can see that the quantity of the positive metabolite produced by chemical 1 is much higher than the quantity of the same metabolite produced by chemical 2. We can conclude that the difference in the experimental results for both chemicals is due to significant differences in the quantities of the active metabolites. The quantity of the metabolite with identified DNA alert produced by the second chemical is found to be not enough to cause effect. Thank you for watching this video and don't forget to like our channel. If you are interested in the Time software, please contact us at the email address or website below.